Have you ever wondered how our universe began? This is a question that has troubled scientists for centuries. It's a difficult task for even the most brilliant minds to overcome, but that doesn't mean we haven't made progress. Thanks to Edwin Hubble, there was a breakthrough in the 20th century. Using his telescope, Hubble discovered not only the rotating gas clouds but also the vast Milky Way, and many of them, even more surprisingly, found that they were all moving away from us. This means an important thing: the universe is expanding. An expanding universe suggests, well, a beginning scientist spent years developing a theory to explain it. The Big Bang Theory. Here's the mind-boggling part. According to the Big Bang, before the universe began, neither time nor space existed. Matter was nothing, except perhaps for one thing. This is a hypothetical state of the universe where it was incredibly small, dense, and burning hot. Imagine squeezing our entire universe into a marble. We're talking about the same kind of density. Scientists believe that the extreme pressure and temperature within this singularity eventually became too high, causing a massive expansion. Big Bang now grand finale at a high Big Bang? It wasn't just an explosion. It was a colossal explosion of energy and matter that created everything we see around us. And everything from the vastness of time to the fundamental forces that govern the universe came into existence at this moment. The Big Bang also scattered tiny particles called quarks everywhere. These basic building blocks of our world swirled in an incredibly hot cosmic soup. They were like bits of spice. As the universe cooled, gravity took over. The quarks stuck together, became atoms, then molecules, and eventually became stars, the first objects in the universe. This incredible change happened within a relatively short time frame. About 12 to 14 billion years ago. Although the Big Bang explains the birth of our universe, it does not answer everything. Enter Alan Guth, an American cosmologist who has devoted his career to solving this cosmic puzzle, seeing some anomalies in the Big Bang Theory. For example, the distribution of matter in the universe seems strangely uniform. Imagine dropping a balloon full of pants on a canvas. The pants would scatter randomly, not in a smooth pattern like we see in our universe. Guth proposed a different scenario, painting a small red dot on the canvas instead of a chaotic explosion. Now imagine inflating that point rapidly. This inflationary theory suggests a period of incredibly rapid expansion before the Big Bang, which explains the uniform distribution of matter in the universe. Imagine filming the early universe with a high-speed camera. Instead of a chaotic explosion, see the full circle continuously expanding in all directions. Guth discovered this incredible monomorphism. Inflation theory proposes a period of incredibly rapid and uniform expansion before the Big Bang. This explains why matter is so evenly distributed throughout the universe. The God theory is widely accepted and is the cornerstone of modern cosmology. While inflation solves some puzzles, others persist. Enter Martin, a German physicist who took a different view on the birth of the universe. This is where things get weird. Proposes quantum time. Unlike our smooth-flowing time, quantum time is jerky, with small jumps and interruptions. Imagine the second hand of a watch that does not move smoothly, but stops and starts at small intervals. In this view, the beginning of one time segment is the end of another, forming a continuous cycle. The Big Bang Theory suggests that our universe is constantly expanding. However, some theories such as the Big Bounce propose a different future. Imagine a balloon. According to the Big Bang, it is always expanding, but the Big Bounce suggests that it will eventually reach a maximum size, then return to an eccentricity, starting the cycle anew. So if the Big Bang created everything, then the theory of where did it come from offers a mind-bending thought. The universe bounces. The Big Bang was not the absolute beginning, but rather the end point of the collapse of the previous universe into a singularity. Our universe is one of a chain reaction of endless bangs and bounces. This theory, while logical, lacks concrete evidence and remains speculative, but some cosmologists push the boundaries even further. Imagine venturing completely beyond our universe. And physicists like Paul Steinhardt have proposed a multi-year one. Not just an infinite number of universes, but an endless Big Bang within our universe. He suggests that our universe is just a membrane floating in a vast sea of others, experiencing endless cycles of birth, death, and rebirth. This diverse idea sounds like science fiction, but hear them out. According to this theory, our universe exists on a membrane which is a giant vibrating surface. This membrane can expand, contract, and even collide with other membranes, potentially explaining the origin of our universe and the existence of countless other membranes. There is a thread in this as a multi-year idea. Countless universes exist alongside us. Turek and Steinhardt propose that these universes reside on nearby branches, like giant sheets of fabric vibrating in higher dimensions. These branches are not isolated. They can talk. In his theory, the branches gradually move closer together until they collide. This epic collision will not be a violent explosion but the creation of two new Big Bangs, giving birth to two new universes, which will then separate. Our universe may be at this stage, emerging from a brandy collision and now on its own. Expanding, but the story doesn't end there. As the universe expands and eventually contracts, the branches can collide again to start another cycle of birth and rebirth. This contradicts the theory of inflation, where a mysterious force inflated the early universe. Perhaps brain collisions may be the source of that inflation. This is a simplified picture. The idea of our universe as a cloth on a string may seem strange, but it has its roots in complex theories such as string theory and M-theory, the cornerstones of quantum mechanics. As if these theories are true, they could explain the grand design of the universe, from the tiniest particles to the vast expanses of space. Developing such theories is an important task, and Steinhardt's work involved extensive calculations, pushing the boundaries of scientific inquiry. The path to understanding the origin of the universe is not paved with easy answers. Highlights the challenges to be faced. Many promising ideas flow, and venturing into the unknown realm of 11 dimensions truly thrills the human mind. Not surprisingly, such radical theories face initial skepticism. New ideas like coal, Earth, or the Big Bang clash with established beliefs, but as Hart points out, fear of the unknown should not be a barrier to exploration. Right now, all three major theories hold some weight: Big Bang, inflation, and the multi-year. Unfortunately, we lack definitive evidence to declare a single winner. It doesn't mean we give up. Theorizing is an important step in scientific research. Perhaps some future discovery will shed light on this cosmic mystery. One day we may finally crack the code and understand the origin of our universe. Till then, the journey of exploration will continue. If you enjoyed learning about these amazing ideas, then like this video and share it with others.